NASA's Starliner mission, intended as a brief test flight, has become a high-stakes drama. Astronauts Butch Wilmore and Sunita Williams are now stranded aboard the ISS after significant malfunctions in the Starliner spacecraft's thrusters, and a helium leak jeopardized their safe return. Originally slated for an 8-day trip, their mission has stretched into months as NASA and Boeing scramble to troubleshoot these critical issues. The stakes couldn't be higher. This isn't just about getting the astronauts home, it's about the future of Boeing's role in space exploration and NASA's ability to maintain multiple spacecraft options. This video will dive into this mission's technical failures, contingency plans, and broader implications. This mission was supposed to be Boeing's big moment, a straightforward 8-day test mission designed to certify the spacecraft for future NASA missions. However, the journey quickly turned from routine to precarious. The spacecraft encountered significant technical issues shortly after launching on June 5, 2024, from Cape Canaveral. These problems became apparent when 5 of Starliner's thrusters began malfunctioning as the spacecraft approached the International Space Station ISS. Out of these 5, 4 thrusters failed during the docking process. To make matters worse, a critical helium leak was also detected, a problem that had previously delayed the mission's launch multiple times. The helium leak, essential for maintaining thruster pressure, raised serious concerns about the spacecraft's ability to safely return to Earth. The root of the malfunction lies in the Starliner's propulsion system. The thrusters are essential not only for docking maneuvers, but also for the critical deorbit burn that is required to safely re-enter Earth's atmosphere. NASA and Boeing engineers have been working around the clock to diagnose the issue. However, the challenge is amplified by the fact that a visual inspection isn't feasible while in orbit. Instead, engineers are relying on telemetry data and testing similar components on Earth. The White Sands Test Facility in New Mexico is a focal point for these efforts, where a duplicate of the Starliner's thruster system is undergoing rigorous testing to replicate the conditions of the mission. Engineers are particularly focused on understanding the helium pressurization system, the heaters that control the thruster temperatures, and the software that manages these systems. Despite the ongoing tests, NASA and Boeing have emphasized that the thruster malfunctions should not prevent Starliner from completing its mission. However, given the uncertainty, they are exercising extreme caution. This approach is necessary given the spacecraft's troubled history, which includes multiple delays, budget overruns, and now, a critical mission failure. The current goal is to ensure the safety of astronauts Butch Wilmore and Sunita Williams before attempting re-entry, but the timeline remains uncertain. The complexity of the situation underscores the challenges inherent in space travel, especially when dealing with new spacecraft technology. The lessons learned from these issues will be crucial for future missions, not just for Boeing, but for NASA's broader goals in space exploration. Given the significant technical issues with Starliner, NASA and Boeing have been forced to explore a range of contingency plans to ensure the safe return of astronauts Butch Wilmore and Sunita Williams. One of the primary options being considered is to use SpaceX's Crew Dragon spacecraft to bring the astronauts back to Earth. This plan would involve launching the Crew Dragon with only 2 astronauts instead of the usual 4, leaving 2 seats empty for Wilmore and Williams. This approach would require significant adjustments to the current mission schedule, but could offer a more reliable return option given the uncertainties surrounding Starliner. Another, more drastic contingency plan involves returning the Starliner to Earth without any crew aboard. This option would rely entirely on the spacecraft's automated systems to execute a safe re-entry. While this would eliminate the immediate risk to the astronauts, it comes with its own set of challenges and uncertainties. The thrusters, which have already proven unreliable, would need to perform flawlessly during the critical deorbit burn. Additionally, the spacecraft would need to navigate the complexities of atmospheric re-entry without the possibility of real-time manual adjustments by the crew. If successful, this plan could allow Wilmore and Williams to return aboard the Crew Dragon during a future mission, potentially early next year. NASA's decision-making process is further complicated by logistical challenges aboard the ISS. The station is currently juggling multiple missions, including a Soyuz resupply mission and the planned launch of Crew 9. The timing of these missions is critical, as the ISS limited docking ports and resources to accommodate multiple spacecraft simultaneously. NASA aims to finalize its decision by the end of August, but the timeline remains fluid. The agency must carefully balance the astronauts' safety, the spacecraft's technical reliability, and the broader implications for future missions. Regardless of the outcome, the decisions made in the coming weeks will set a precedent for how NASA and its commercial partners manage unforeseen challenges in space. The technical challenges faced by the Starliner mission have far-reaching implications for NASA, Boeing, and the future of human spaceflight. NASA's Commercial Crew Program, which includes both Boeing's Starliner and SpaceX's Crew Dragon, was designed to end the agency's reliance on Russian Soyuz spacecraft for transporting astronauts to the ISS. While SpaceX has successfully met this challenge with its Crew Dragon, the repeated issues with Starliner raise concerns about the feasibility of maintaining multiple spacecraft options. If Starliner proves unreliable, NASA may have to reconsider its strategy of relying on both Boeing and SpaceX to fulfill its crewed mission needs. For Boeing, the stakes are incredibly high. The Starliner program has already been plagued by delays, budget overruns, and technical failures. Completing this mission is crucial for Boeing's reputation and its future in the space industry. A failure to resolve the current issues could have long-term consequences, not just for Boeing's relationship with NASA, but also for its broader ambitions in commercial spaceflight. The situation also highlights the challenges of managing large-scale, high-risk projects in collaboration with public agencies. The pressure is on Boeing to demonstrate that it can deliver reliable spacecraft, or it risks losing its standing as a key player in NASA's space exploration plans. From NASA's perspective, the Starliner situation underscores the risks and complexities of human spaceflight, particularly when working with new spacecraft. The agency's cautious approach reflects its commitment to safety, but it also illustrates the difficulties of balancing innovation with reliability. The lessons learned from this mission will be crucial for shaping NASA's future partnerships with private companies. If Starliner can overcome its challenges, it could still play a significant role in NASA's plans. However, if the spacecraft continues to falter, NASA may need to rethink its strategy and place greater reliance on SpaceX or other potential partners. Ultimately, the outcome of the Starliner mission will have a profound impact on the future of space travel. It will influence not only the future of NASA's crewed missions, but also the broader landscape of commercial spaceflight. The decisions made in the coming weeks will set a precedent for how NASA and its partners handle unforeseen challenges and will shape the trajectory of human space exploration for years to come. In this video, we have learned about the unexpected challenges faced by NASA's Starliner mission, the critical technical issues that stranded astronauts aboard the ISS, the contingency plans being considered, and the broader implications for NASA and Boeing. We hope you learned something new. If you did, please give us a like, share, and subscribe to our channel for more videos like this. Don't forget to leave a comment below and tell us what you think about this news and what you would like to know more about. We would love to hear from you. Thank you for watching, and see you next time.